Welcome to the session on ratios and proportions. In this chapter, we will deal with one of the basic and more important concepts for all aptitude tests: ratio and proportions. It seldom happens that the ratio and proportion questions do not appear in a test. So, the concept is very important from an aptitude test perspective. It is also a rarity that data interpretation questions do not have the concept of ratio embedded in them. Therefore, understanding ratios has a multi pronged advantage in aptitude test preparations. Very often, we see the scramble for shortcuts to solve these problems, but an adept and sophisticated test preparer can easily break the standard shortcuts that you study. So, it is important that you understand the basics and then study the shortcuts so that in states of emergency you can fall back on the basics to solve the problems. The basic question is, what is a ratio? Ratio is a comparison of two things with numbers in their lowest form. Consider the following example. I have 20 chocolates. You have 30 chocolates. The ratio of chocolates that I have to what you have is 20 is to 30. But we cannot represent the ratio as 20 is to 30. That's a wrong ratio representation as it is not in the lowest form. The correct representation is 2 is to 3 because it is the lowest form in the integral format. That means 2 is to 3 is the lowest form with numbers as we know, without fractions and decimals. In ratios, there is one implicit assumption, that is, we compare like things. We compare apples to apples, oranges to oranges, etc. We will not compare unlike things. We will compare chocolates to chocolates and not chocolates to marks. We know length is measured in meters, weight in kilograms, etc. What will be the unit of ratios? Will there be a unit for ratios? What is a ratio? After all, it is a comparison between two like things. So, do we need a unit for comparison? Mathematically, we have the same unit in the denominator and numerator. So, there is no unit for ratios as the same units in the denominator and numerator cancels each other. A is to B is 2 is to 3 means what? For every 2 portions of anything that A gets, B will get 3 portions of the same thing. So, if A gets 10 portions, that is 5 times 2 portions, B will get 5 times 3 portions, that is 15 portions. A is to B equals 2 is to 3. Does this mean A equals 2 and B equals 3? No, it does not. It means that A will be a multiple of 2 and B will be a multiple of 3. So, the real value of A will be 2x and the real value of B can be defined as 3x. The real values will be a multiple of 2 for A and a multiple of 3 for B. The multiple could be any number. That is why it is usually denoted as x. The only point to note here is that it will be the same multiple for both. It cannot be 5 for A and 4 for B. It has to be the same number. We have reduced a fraction to its lowest possible representation by dividing both by the same number. So, multiply by the same number. Example, 20 mangoes for A and 30 for B. 10 mangoes for A and 15 for B. Both will be the same as far as ratios are concerned. Let us look at ratios from another perspective. A is to B equals 2 is to 3 means that a particular total was divided into 5 parts. Out of the 5 parts, A got 2 and B got 3. How did we know that it was divided into 5 parts? 2 parts of A plus the 3 parts of B will make it a total of 5 parts. Simple. Hence, we get a relation that the total number of parts into which something is divided is a sum of the constituents of the ratios. So, if A is to B equals 2 is to 3 and the sum is 50, it means that 50 has been divided into 5 parts. So, one part is 10 and 2 such parts are given to A. So, A gets 20 and similarly B will get 30. How do we get to the real values of the constituents of a ratio? From the previous examples, we know that we need to get 1. The value of the multiplying factor, that is x, in the representation 2x, 3x, etc. 2. The total value, or 3. The value of the other constituent to get to the real value of A and B. If the multiplying factor is 10, we can find A as 2 into 10 equals 20 and B as 3 into 10 equals 30. The additional information given is that the total of A and B is 50. Therefore, A equals 2 upon 5 into 50, that is equal to 20. B equals 3 upon 5 into 50, that is equal to 30. If A is 20, we know that the multiplying factor is 20 divided by 2, that is equal to 10, and therefore the value of B will be 3 into 10 equals 30. So, to find out real values of a ratio, we need to have either the multiplying factor or the total or the value of one of the constituents. Let us look at another example. A carton of a dozen bottles is unloaded. Can we have a ratio of 2 is to 3 for broken to unbroken bottles? Can we have? Let us work it out. Dozen means 12. Broken is to unbroken equals 2 is to 3, that is given. Total equals a dozen and that equals 12. The real values of broken and unbroken bottles can be 2x and 3x. Therefore, the sum of broken and unbroken bottles equals 5x. Therefore, 5x equals 12 and x will be equal to 2.4. Therefore, 2x equals 4.8 and 3x will be equal to 7.2. Are these values correct? And are these the answers to the question? Is it possible to have such answers? In a mathematical sense, there is nothing wrong with the calculation. But we know from a physical sense that there can be a broken bottle or an unbroken bottle. Nothing in between is possible. So, a possibility of 4.8 broken bottles is not there, and hence the answer is a non-possibility. Look at the slide. The ages of Rama and Lakshmana are in the ratio 3:5. After 9 years, it becomes 3:4. You have to find their present ages. R by L equals 3 by 5, where R is the present age of Rama and L is the present age of Lakshmana. R plus 9 divided by L plus 9 equals 3 by 4. It is said that after 9 years, the ratio becomes 3:4. From the first equation, we get 5R equals 3L. And from the second one, we get 4R plus 36 equals 3L plus 27. Now, solving these two equations, we will get R equals 9 and L equals 15. The assumption here is that you know how to solve the equations. Here, it is given A is to B is to C equals 1:2:3. And the sum A plus B plus C equals 60. And you are asked to find out A, B and C. The real value of A equals 1x. Real value of B equals 2x. Real value of C equals 3x. The total is 1x plus 2x plus 3x, that is equal to 6x. And we know that the total is equal to 60. Here, 60 is divided into 6 parts, and therefore, one part will be equal to 60 divided by 6, that is equal to 10. X equal to 10. Therefore, A is 1x, that is equal to 10. B equals 2x, that is 20. And C equals 3x, that is equal to 30. Why? Because we know the real or original value equals constituent ratio multiplied by the multiplying factor. I'll repeat. The original value equals constituent ratio into the multiplying factor. Let us have a look at the relation between ratio and percentages. It is very important from the aptitude test point of view. What is ratio? Ratio means representation as a part of the total. Let us go back to percentages. A is what percentage of B will imply A by B into 100. Now, if A is to B is to C equals 1:2:3 and A, B and C constitute whole of the system, then A equals 1/6 of the total and therefore 1/6 into 100 percentage. That means A constitutes 16.66% of the total. B will be twice that of A, or B will be 2/6 of the total, or 2/6 into 100, that is equal to 33.33%. C will be thrice that of A, or C will be 3/6 or half of the total, or 50%. Let us look at some more questions. Look at the questions Q7 to Q12. It is given that the ratio of three numbers A, B and C is 2:3:5. Based on that, we are asked to find certain percentage relations between them. Question 7. By what percentage is A less than C? Question 8. By what percentage is B greater than A? Question 9. By what percentage is C more than A? Question 10. By what percentage is A less than B? Question 11. By what percentage is B less than C? Question 12. By what percentage is C more than B? Here, we can consider the real value of A to be 2x. Therefore, the real value of B will be equal to 3x and the real value of C will be equal to 5x. Now, apply principles we learned earlier while we did the class on percentages. We can define the real value of A as 2x, real value of B equals 3x, real value of C equals 5x. Therefore, the answer to question number 7 is 5x minus 2x divided by 5x, that is equal to 3x divided by 5x, that is equal to 3 by 5 equal to 60%. What are the peculiarities that we can note here? The calculation with constituents holds for calculations based on percentages. The constituents can be used instead of the real values. The calculations are more or less same as the previous calculation of percentages. To find out the difference in percentages between two numbers represented by ratios, there is no need to calculate the real numbers or exact numbers. We can very well work with the constituents. The answer to question number 8 is 50%. The answer to question number 9 is 150%. The answer to question number 10 is 33.33%. The answer to question number 11 is 40%. And the answer to question number 12 is 66.66%. Hope you got all the answers right. If not, go back and listen to the whole presentation once again. At the end of this presentation, let us recount what all important points we had a look at. We looked at the definition of ratios, what exactly a ratio means. We looked at how to calculate ratios. What is the importance of multiplying factors? How can ratios be found out from a sum or from a constituent? We had a look at the relevance of the absolute values that we derive mathematically and had a look at how ratios need to be applied sensibly and not looked at only mathematically using the example of bottles. Bottles can never be represented as half broken or half not broken. Hence, we did not take the decimal values. We had a look at the relationship between the concept of ratios and that of percentages as regards converting ratios to percentages. We also had a look at how to solve problems with the concepts. Here is a word of caution. Ratios are familiar to us from our youth itself. It is easy to be self-confident. Do not be overconfident. Thank you and happy learning.